Alright, so here's a little introduction to functions. So an analogy that I like to use for functions is that they're kind of the same as machines. So machines always do the same job all the time to the same part. So a function kind of acts just like that. So here's my machine, just represented by a box. And this function, I'm going to call it function f. F for function. So what this function, what this machine does, is anytime I take some kind of input, I'm going to put something into the machine's going to spit out something else. So everything that I'm putting in is called an input, and everything that the machine spits out is called the output. So functions, instead of being like a paper machine where you put something in and it spits out the paper, a function, what it does is usually you put in a number, it does something to the number, and then spits out a result. So for example, if I say that f is a function that always doubles my input, so then if I put the number 2 into this machine, then since f doubles my input, then it's going to spit out 4. Okay? If I put in another number, let's say I put in -3, well, f is going to take the -3, it's going to double it, and spit out a -6. So it always takes an input, modifies it somehow, and then spits out an output. Now, one other thing is when I put the number 2 in, I got out the number 4. If I were to do it again, say if I take the number 2 and put it in that function machine again, it's going to spit out 4 again. If I were to repeat it again, a third time, put the number 2 in, it's going to spit out 4 for the third time. So the point that I'm getting at here is every time I put the number 2 into this function, the function is always going to double it and get the same output. I'm never going to put 2 into this specific function and get out 7. So my input always is associated with only one output. So 2 in this case is associated with 4. -3 is associated with -6. -3 will never turn around and give me 7 with this machine. Of course, machines can do several different jobs, right? So instead of having machine F, I could have machine G. And machine G might take my number, double it, and then subtract 1. So machine G, let's say I'm going to put the number 2 in again. So if G doubles and then adds 1, it's going to take 2, it's going to double it to get 4, and then add 1 and spit out 5. If I were to take the number 0 and put into G, G is going to double 0, which gives me 0, and then add 1, which gives me 1. Okay, so that's just another machine, another function. So functions can be represented by different letters, and they can do different operations to the inputs. They don't always have to do the same operations. So I could use function J that takes my input, triples it, and subtracts 1,000, for example. That would just be another example of a function. Now, function notation looks a little bit wonky, but what it does is it names the function using a letter. So in the case of the first function I have, it would have said, all right, my function is f. Now, I also have to give these inputs a name. Since the function has a name, I need to give the inputs a name. Inputs are usually referred to as x values. X's are usually the inputs. So the function notation tells me the name of the function, which in this case is f. That's a little bit dark, I'll make it dark. The name of the function is f, and then the function notation also tells me what variable is the input. So if this is f, my input variable could be x. So the function notation could be f of x. So an example of function notation would be if I have f of x equals 2x. So this was the first function that we did. It was function called f. It depended on x values. And what it did to the x values is it took the x's and multiplied them by 2. Another one, I could have function g. Function g also depended on x values. And what function g did is it took the x values, it doubled them, and then it added 1. So I could say that g of x, this is how this is read, g of x and f of x. So g of x is equal to 2x plus 1. Of course, I could also have, h of t equals negative 5t minus 3. That could be another function as well. So what this function is, it's called function h. It depends on t, so t is the input that goes into the box. It's going to take your t values, multiply them by negative 5, and then subtract 3 from that result. So that's all that function notation does. It tells you the name of the function, and then it tells you what the input is. And then on the right hand side it gives you the rule or the process that the machine follows. So let's look at an example. So I have f of x is equal to 3x minus 4. So this is a function f. The inputs are x values. What the machine does is it takes my x's, it multiplies them by 3, and then subtracts 4 from the result. So what I can do is I can put different x values into the machine, different inputs into the box. So let's take the value 1. I'm going to put 1 into the box. So what I'm doing is I'm replacing the x value, is I'm saying, okay, the x that I'm putting in is going to be 1. So this is called f of 1, meaning that I'm replacing the x with the 1. And then on the right hand side, I also, anywhere I see x, I replace it with 1. So this would be 3 times 1 minus 4. Then of course to evaluate this, 3 times 1 is 3, and then 3 minus 4 is negative 1. So I could say that f of 1 is equal to negative 1 for this function. Let's do one more. How about f of 6? Well, same thing. So I would replace the x with 6. So this would be 3 times 6 minus 4. 3 times 6 is 18. 18 minus 4 is 14. So I could say that f of 6 is equal to 14. Okay? All right, so let's look at, so what we've done there is we're taking inputs and putting them into the box. We're finding out what the machine spits out, right? Well, we can also work backwards. If we know what the machine does and we know what the machine spit out, then we can find out what was put into the machine in the first place. So here's an example of that. So let's say if we have machine F, actually let's use a different letter just for a little bit of variety. Let's say we have machine M, and what it does is it uses L as my input. So this is function M, and L values go into the box. So what M does is it takes my L values, multiplies them by 2, and then adds 1. So this is the box, the machine. The machine is M, and it depends on L's. So let's say that when we put something into the machine, it spit out 11. So that means that we were given that whatever this L value is, M spit out the number 11. So m of L was equal to 11. Then what I'm going to do is find out what that L value that was put in was. So what I will do is take this original here, and since this says m of L is equal to 11, I can replace this expression here with the number 11, the whole thing, not just the L. So what I end up with then is 11 equals 2L plus 1. And now to find out what the L value is, just a little bit of algebra. I have to get rid of the 1. So this is plus 1, so to get rid of the 1 I would subtract 1 from both sides of the equation. 11 minus 1 gives me 10 equals 2L. 1 minus 1 cancels off. And then to find out what L is, I have to get rid of the 2. I would do that by dividing by 2. What you do to one side of the equation, you have to do to the other side, so then that would tell me that L was equal to 5. So that means that since m spit out the number 11, it must have been the number 5 that was put into the function initially.